Okay, so now we are going to do this stoichiometry of how to figure out, if we're given a mass of something, how much of the other thing are we actually going to get. So in our reaction, we figured out that when you add sodium hydroxide to magnesium chloride, there's going to be a precipitation reaction occurring. You'll produce magnesium hydroxide, and you're going to have sodium chloride ions in solution. Something I forgot to mention in the last video, that this here is the precipitation reaction. However, we have what we call our spectator ions. The spectator ions are literally going to be sodium ions and chloride ions, because these are the ions that don't actually take part in the reaction. Just like imagine that if all these ions were at a game, let's say an AFL footy game, magnesium and hydroxide ions would be the actual players. They'll be out on the field, whereas these sodium and chlorine, they're out in the grandstand. They don't take part in the game, but they're there. They're there to watch. They'll participate, and they're still within the mix. Okay, so they don't actually take part in our particular reaction. However, they still make up the mass, or they still make up the numbers in the stadium itself. So you as a spectator, you still make up the numbers in the stadium. So that sodium here is still important. Now I changed the numbers a little bit. It used to be 20 grams. I changed it to 20.02 grams so that we will start to look at significant figures. Now with this one, 20.02 grams, this will have 4 significant figures, because if we were to change that to scientific notation, it would become 20.02 grams would be 2.002 by 10 to the 1 grams. Okay, so now that we have that, we can still use this value, but because now it's a bit more of an accurate value, we can actually come up with a bit more of an accurate number. So first, let's actually state the information that we have. So the property, the mass of the chemical sodium hydroxide is 20.02 grams. Let's figure out the molar mass of sodium hydroxide. Now, if you don't know yet how to figure out the molar mass of sodium hydroxide, I have another video in order to actually explain how to figure out the molar mass. And the molar mass of sodium hydroxide is just simply going to be 22.99 according to our periodic table, plus 16 plus 1.008, which is 39.998 grams per mole. So for every mole of sodium hydroxide, it weighs 39.998 grams. Okay, now that we know the molar mass, we need to find out a third property, which is the number of moles of our sodium hydroxide. Now, in order to figure this little relationship out, we're going to need our trusty little triangle. So our trusty little triangle is just this guy. Okay, we have little m, big N, little n. So with this guy, as long as you know 2 out of the 3 bits of data, you can figure out the third. If we know the mass, we can figure out the molar mass using our periodic table, so we will be able to figure out our number of moles. Okay, so let me just get this color. Alright, so we can figure out the number of moles of sodium hydroxide, which is just simply the mass of it, which is 20.02 grams, divided by 39.998 grams per mole. Which should be And the best way to do this is to put it in scientific notation. 5.01 approximately by 10 to the negative 1 moles. Okay, so we know the number of moles of our sodium hydroxide. Now, if we look at our original reaction, because we've balanced it, there is this thing called molar ratio. So the molar ratio, the ratio of the number of moles in this reaction according to the coefficient, is going to maintain the same. So if there's no number in front of the chemical, we can assume that it's a 1. So in the reaction, for every 2 moles of sodium hydroxide, we need 1 mole of magnesium chloride, and you'll produce 1 mole of magnesium hydroxide and 2 moles of sodium chloride. So, according to our molar ratio, we can now compare what we want to know, magnesium hydroxide, to what we do know, which is how much sodium hydroxide we actually have. So, let's do that. Let's figure out how much magnesium hydroxide we have. Okay, and compare that with what we do know. We know for every 2 moles of sodium hydroxide, we produce 1. So 1, the number 1 is half of the number 2, right? So we know for every mole of sodium hydroxide, you will have half the number of moles of magnesium hydroxide. So if we halve the other value, we should get 2.50, yeah, say 2.50 by 10 to the negative 1 moles. So now we have the number of moles. Let's use our little triangle. Let's figure out the molar mass of magnesium hydroxide. So let's have a look at our periodic table. Magnesium is 24.31 and oxygen is 16 and hydrogen is 1.008. However, we have 2 hydroxides, so it's going to be 24.31 plus 2 times 16 plus 1.008. Oops, squeeze that in, which is going to be 58.326 grams per mole. So now that we know the molar mass, we can actually figure out the mass, the final mass. The final mass of our magnesium hydroxide is just the number of moles of magnesium hydroxide times the molar mass of magnesium hydroxide. Oops, sorry for the messy writing there. I'm trying to squeeze it in, which is going to be 2.50 by 10 to the negative 1 times 58.326 grams per mole. And that's a 1. Which I'm going to have to put the answer here. I apologize because we just simply ran out of room. Our final answer is going to be it should be approximately 14.58 grams. Now, on my calculator, I have 14.5815. Now, in terms of significant figures, we need to have a look at our very final number. This will be, we'll figure out how many significant figures we have. We need to just figure out what is the least accurate number that we used that has been measured. Those will be the molar mass, The molar masses are measured numbers, and also your masses are measured numbers. As we discussed here, this mass has 4 significant numbers: 1, 2, 3, 4. Our molar mass of our sodium hydroxide has 1, 2, 3, 4, 5 significant figures, and our molar mass of our magnesium hydroxide also has 5. 1, 2, 3, 4, 5. So the smallest number of significant figures is our mass here, 20.02. So we need to show it to 4 significant figures. So 14.5815 to 4 significant figures would be 14.58 grams. And there you go.